All right, here we go. So this standard, the next section will be on applying derivatives. So we've done all this work for how do we figure out a derivative for a variety of types of functions, and now it's going to be mostly about applying it, okay? And we're actually going to step back into the hard copy textbook. The reason for that is twofold. One, I have some of my previous plans made for that textbook. And two, I just got an email from NCC that's saying next year I'm supposed to use that textbook instead of the online textbook. So they keep changing it, and so I'm just going to save myself some time and effort and just continue working with that and say this year we're still using the online textbook, but not always using the online textbook. Make sense? Anyway, that's the plan. So we're going to primarily go through chapter 4 of the book. And so kind of the big ideas to keep in mind. How derivatives help us understand graphs of functions. Okay, obviously we have Desmos and graphing calculators, which are tremendous resources that in some ways make some of the stuff we're talking about with graphs kind of irrelevant. But at the same point, if we understand derivatives, they just give us a deeper understanding of what's happening in these graphs of functions, okay? We'll definitely dig into practical uses. Do you guys remember way back when we started pre-calculus, the marshmallow, make it hold the most? Remember that right away, first day? Those optimization problems, okay? So this is where all that work we did back at the beginning of, well, August and September, it's gonna really come back to be helpful because not only are we creating the functions, but now we're gonna use what we know about calculus to work with them, okay? So that, and then this thing called linearization and Newton's method, don't worry about that for now. Okay, so today we're just gonna talk about extreme values of functions. All right, so you should have this on your notes page there. You can look quickly at those goals for the day. Vocab is gonna be key, and just being more confident about working with graphs. So go ahead and flip the page. As I already mentioned, Desmos, GeoGebra, I guess, and graphing calculators are super, super helpful. And so what I'm hoping though is that you guys understand the calculus behind the graphs though. And that's what the lesson is all about. So please take a moment and read the paragraph down there below. Okay, and then look down there below at the vocab. These are four key vocab terms that you need to be aware of, okay? Absolute minimum and absolute maximum, those are obviously the lowest and highest points on a function, on a graph. And then local maximum and local minimums, those are just kind of nearby that spot if they hit kind of a high point or a low point, but not overall. Hopefully that's pretty straightforward and makes sense with that, okay? All right, so we're moving right along here. I'm gonna put you guys to work for just a second. Grab a marker, come up to the board. See if you can draw an example of a function that has each one of these things, okay? So you can take this sheet with you or just look up here and see if you can draw an example. And I would say draw it as a graph, right? So draw the function as a graph.